Welcome to part 37 of our series on building a Zelda-like game in Phaser 3. In this video, we'll continue improving our combat system by creating a base weapon class and implementing a sword class for the player. We'll also update the player class to handle attacks, add animations for all directions, and set up weapon collisions with enemies. If you're new here, this is part of a full series where we create a Zelda-inspired game from scratch. Check out the playlist link in the description to start from the beginning. Alright, let's dive in and refine our weapon system. Now that we have our attack state and our weapon component in place, it's time for us to move on to creating our first weapon, our sword. So for the weapons we create in our game, we're going to create a base class that all of our other weapon game objects will extend. This will be similar to our base character class, where our base weapon class will have all of the core functionality that'll be in common between our various weapons. And so our base weapon class will have a lot of our core logic tied to things like our sprite game object, if our weapon's currently attacking, as well as our animation configuration for which animations need to play when we attack with our weapon. To start working on our code, let's open up our base weapon file that we created previously. And currently we have our interface that our weapons need to implement, and now we'll add our base class that all of our weapons will extend. So let's do export, we'll do our abstract class, let's do a base weapon for our name, and then we'll do implements weapon. Since we're implementing our weapon interface, we'll need to add these methods and properties to our class. To get us started, first we'll define our protected properties on our class. So let's add in protected. First, we're going to add a reference to our weapon component that this weapon is associated with. And so we'll do our weapon component, and so for our type, that'll be our weapon component. Next we'll do protected, and we'll do attacking. This will be our boolean. And then we'll want to do our protected. Let's do our base damage. This will be our number. Now we just need to add two more properties. Our first one is going to be our sprite game object that will represent our weapon in our game. So this will be our phaser, our game objects, and then our sprite. And then for our second property, this will be our attack animation config. And for this, we'll make a new type, and we're going to call this our weapon attack animation config. And so our attack animation configuration, this is just going to be a map between our directions and which animation we want to play when we attack in that direction. So let's define that type real quick. So let's do export type. We'll do our weapon attack animation config. This is going to be an object. And now for our keys on our object, this will be our key and direction. And then for our type, it'll be a string. And so this will just be a map between our various directions, so up, down, left, and right, and our animation key we want to play. So now that we have our properties, let's add in our constructor. So for our constructor, first we'll need our sprite game object that represents our weapon, and so this will be our phaser, our game objects, our sprite. Next we'll need the weapon component that's associated with this weapon. Then we'll need our animation config. So we'll have our weapon attack animation config for our type. And then we'll have our base damage, and this will be a number. So now in our constructor, we can update our properties. So our sprite will be equal to our sprite. Our weapon component will be equal to our weapon component. Our animation config will be equal to our animation config. And then our base damage will be equal to our base damage. Then finally, we'll add in a default value for is attacking, and so we'll set that to be false. So now that we've updated our properties, we need to add in getters for our base damage and is attacking. So let's do get, we'll do is attacking, this will return our boolean, and so we'll just return this attacking. Now we'll do get, let's do our base damage, this will return our number, and so we'll return this, our base damage. Next, now we need to add in our methods that we'll need for our weapon interface. So I'm going to copy these here, let's come down to our code, let's paste those in. So now for our attack up, down, left, and right methods, we don't actually want to implement these on our base weapon class, and instead we want to force our child classes to implement these. To do that, we can make these methods public, and then we can use abstract, and now we have these defined on our parent class, and we'll need our child class to actually implement these to have the logic that we need. So as an example, when we create our sword and we do our attack up, this is where we'll play our animation for our sword swinging in front of our player, and we'll update our weapon's physics body at that time. So now we'll do the same thing for our other attack methods. It's now for our update and our on-collision callback methods. We'll want these to be optional on our child game objects. So we're going to define those methods on our class here, but we won't have them do anything. And if they need to be overridden, we'll do that in our weapon implementation. And to do that, we'll just make these methods public. And now let's add in our method. And for now, we're just going to add a comment about not implemented. And now we'll do the same thing for our other method. And now we'll save. Now that we have our base logic in place for our base weapon, let's create our sword class. So under our weapons folder, let's make a new file. We're going to call this sword. So now let's export our class. So we'll export class sword, and we're going to extend our base weapon class. So now in our class, we'll need to implement our 4 methods for when we want to attack. So I'm going to jump over to our base weapon class, and I'm going to copy these methods from here, paste them into our class. We'll get rid of our abstract keyword. Now let's add in our methods. Alright, so let's start with our attack up method. So when we go to attack with our weapon, the first thing we'll do is we need to set our property to show that we're currently attacking, and we want to set that to be true. So after we set attacking to be true, now we need to play our animation for actually attacking. So we'll reference our sprite game object that's associated with our weapon, and now we want to call play. And now for our animation configuration, we'll have our key, and now for our key, we want to grab this from our attack animation configuration here. And so we'll do this, we'll do our attack animation configuration, and now we want to do our up direction, and then we'll set a repeat, we'll set that to be 0, and then after our configuration, we want to set ignore if playing to be true. So once we start our animation, now we'll want to enable our physics body on our game object, and so we'll reference our weapon component, we want to grab our body, we want to do enable, and we're going to set that to be true. Once we start our animation, now we need to wait for it to finish, and once it's finished, then we'll want to set is attacking to be false, and then disable our physics body on our weapon component. To do that, we're going to do this.sprite. We want to use the once for our event listener, and now for the event we want to listen for, this is going to be our phaser, our animations, our events, our animation complete key, and now we need to add on our suffix for the animation that we just played. And so that's going to be the same key that we're using here. So what we'll do is we're going to store this in a variable so we can reference it in the same spot. So let's copy this here, make our new variable, do const, we'll do our attack animation key, and we're going to set equal to this, our attack animation config, and then up. Now we'll replace that here, and then we'll paste that here. And then in our callback, now we just want to set our attacking, we're going to set to be false, and now we'll disable our body. And so I'm just going to copy this code here, we'll paste it, and let's set this to be false. So now if we want to test the logic we have so far, let's jump over to our player class and we'll create an instance of our weapon component and our sword. We'll need to keep track of our weapon component. Let's come to the top of our class, we'll add a new property, we'll do our weapon component. For this, we'll set it to our weapon component type. Now we'll come down to where we add in our components, we'll do this, we'll do our weapon component. It's going to be equal to a new weapon component instance, and we'll pass in this for our game object. So now we'll want to create an instance of our sword game object and assign that to our weapon component. So we'll do this, we'll do our weapon component, we'll do our weapon, we're going to set that equal to be a new instance of our sword game object. So now for our sword, we want to pass in this for the sprite game object we'll be using, and now we need to pass in our weapon component, and now we just need to do our animation configuration. So for this, we'll need to provide our attack directions, and so we'll have down, and now this will be our player animation keys, and this will be our sword 1, and then our attack down. Now I'm going to copy this, and we just need to do our 3 other directions. So we'll have up, left, and then right. And now for our animation keys, this will be our sword 1 attack up, and then our sword 1 attack side. And then finally, we just need to pass in our base damage, and for the time being, we'll do 1. Finally, we'll need to go down to our update method, and now we want to call this our weapon component, and we'll want to call our update method on our component. Alright, finally for our player, let's add a getter for returning our weapon component. And so let's do get, we'll return our weapon component. For our type will be our weapon component, and now we'll return this and our weapon component. One last change we'll do is when we create an instance of our sword, let's remove our hard-coded 1 here. We're going to grab this from our config file. So we open up our config file, let's copy this line of code here, we'll paste it, and now we'll have our player, and we'll have attack damage, We'll have a base value of 1. Come back to our player class. Let's remove our 1 here. Now let's reference our new variable, and so we'll have our player attack damage. Alright, so now if we come over to our browser, we should be able to test our changes. If we have our player face down, left or right, and we try attacking, nothing should happen. But if we face up, oh, looks like we have an issue. Let's jump over to our sword class. Yes, we are referencing phaser, so we just need to import that. So we'll do import as phaser from phaser. Alright, so now if we come back to our browser, if we try again, if we do left, right, or down, nothing should happen, but when we attack up, we should see that our player plays our animation for attacking with our sword. Alright, so one thing to note is when we create our sword instance in our player class, we passed in a reference to our player sprite. The reason we did that is our sprite sheet for our player, our weapons are currently baked in to our player, and so when our player goes to attack, our weapon is there with our player. As an example, if we go under our assets folder, our images, if we go into our player and open up our main_green PNG, we'll see when we attack with our sword is in our player's hand and it's all one animation. This is important to know since we'll need to update our player sprite game object to play that correct animation. If these were broken up, we need to handle this differently. And another good example is once we go to do our dagger for our boss enemy, we'll see our sprite sheet is just our game object itself, and it's not attached to our boss. What this means is with our weapon game objects we create, we'll need to be able to dynamically pass in whichever sprite game object represents our weapon or the animation we need to play. Now that we verified our animation for attacking in the up direction is working, we want to do the same thing for our other directions. For the time being, let's just copy this block of code here, and we'll paste it in our various methods. And then we'll just want to update our animation configuration key. And so when we attack left, we'll do left, and we'll do right, and let's do down. So now if we save and come over to our browser, if we have our player try attacking in our various directions, we now play the appropriate animation for that attack. And then our player will go back to our idle animation once that's done. Now that we verified our logic for playing our various animations based on our attack direction is working, we're going to work on refactoring our code since a lot of this code is the same between all of our various attacks. Since we're repeating this pattern, it makes sense to move this logic to our base weapon class, and then that way we can reuse this for all of our various weapon implementations. So let's jump over to our base weapon class. We'll add in a new protected method, and we'll call this attack. So let's do protected, we'll do attack. Now for this method, we won't return anything. Let's jump over to our sword class. Let's copy our logic for our attack animation. We'll paste that. And so to make this dynamic, we'll want to pass in our direction of our attack. So we'll add an argument, we'll call this direction, and now we'll do direction for our type. And now for animation config, we'll reference that key, so we'll pass in our direction. And now the rest of our code should stay the same. But one thing we'll do is our callback here, we're going to move this logic to its own method, and then that way we'll be able to reuse that as well. So let's add in one more method. We'll do protected, and we'll do attack animation complete handler. For this method, we won't return anything. Let's grab these 2 lines of code, let's paste it, and now we'll call our new method. So we'll do this, and now we'll do our attack animation complete handler. So now if we jump back to our sword class, let's update our attack methods. So for our attack up, we're just going to call this attack, and now we'll pass in our direction. So we'll do direction, and we'll do up. Now if we copy that line of code, let's update our other methods. Now we just need to update our direction, and so we'll have left, we'll do right, and then we'll do down. And then let's grab our import for phaser, and we'll move that over to our base weapon class. Now let's save, and if we come back to our browser, and now when we try attacking, we should still play our animations for attacking in our various directions. Now that we have our logic working for playing our various attack animations, now we need to layer in our logic for updating our weapon's physics body. So when our player attacks in the upward direction, we'll want to move our physics body in front of our player, and we'll want to have a horizontal rectangle box for our sword's attack. Versus when we attack on our side, we'll want to have our physics body next to our player, and we'll want to have a vertical rectangle representing the path of our sword. So to add in those changes, let's start in our attack up method. First, we'll want to update the size of our physics body. And so we'll do this. We'll reference our weapon component. We want to grab our body from it, and now we want to call set size. For the size, we're going to do 30 pixels for our width, and we'll do 18 pixels for our height. And now we'll want to update our position to be in front of our player. So let's reference our weapon component, our body. We'll reference our position property, and now we want to call set. And now we'll need to reference our sprite game object that's associated with our weapon. So we'll do this, our sprite. We'll grab our X value. And then we'll need to do our Y value. So we'll do this.sprite. And now let's do our Y value. All right, so if we save, we come back to our browser, we should see a little pink dot on our square, and this is representing our physics body of our weapon component. Right now it's disabled, and when we attack in our upwards direction, it should now disappear and reappear at the position we specified. And so now we can see we have this large rectangle box at the position here where our player is. And so we'll need to update our X and Y values to have it be placed in front of our player. So first for our Y value, let's subtract 22. Now if we have our player attack in the upwards direction, we have our box in front of our player, but we need to shift it over a little bit since our sword animation kind of starts here and moves all the way to over here. So now for our X value, we'll subtract 16. Now if we attack in our upwards direction, our physics body is now more aligned with where we're playing our attack animation. And so if we move around our scene and keep attacking in the upwards direction, we should see that our position gets updated. So now we'll want to do the same thing for our other directions. Let's copy these 2 lines of code, we'll paste them in our various methods, and we'll start with our attack down. So for our attack down, we'll keep the same size, but now for our positioning, we'll want to update our Y value, we'll want to increment this. So we'll increase this by 10. Now if we save, we come back to our browser. If we have our player attack down, we'll see our box is pretty close, but let's update our positioning and we'll subtract 20 from our X. All right, if we save, let's have our player try attacking down. So it looks like we need to update our X position a little bit. But if we move over to the left and then face down, now we'll see our box works for our position. And if we move to the right, now we have that same issue where we just attacked down. So what's happening is when we move left and right, we're updating our flip X property on our sprite. And so when we do that, we'll need to account for that when we set our X position. To account for that change, we'll just do if, we'll do this, our sprite. If our flip X is set to true, then we'll do this line of code here. Otherwise, let's copy this. We'll use a different X value, and so for our X value, we're going to subtract 10. So now, when our scene refreshes, if we attack down, we'll see our box should match the direction of our sword. If we move to our left, now it matches when we have our flip X property set to true. Now if we move to our right, it goes back to how it was before. Nice. Alright, so now we just need to do our left and right directions. So for our left and right directions, we need to have our game object to the left or the right of our player. So for our position, for our X, when we're attacking to our right, we'll want to add 10. When we are facing to the left, we'll want to subtract 30. And now for our position, we only want to subtract 10 for our Y. So now if we attack to our left or right, we get our game object in the right position, but we just need to update our size. And so now for our size, we'll want to flip these values. And so we'll do 18, and then we'll do 30. Alright, so now if we move around, we should see when we attack, our physics body gets updated to be in the position that we need it to be in. Now that we've added in our logic for having our player be able to attack and play our animation and update our physics body, now we just need to bring everything together by adding in our collision check between our player's weapon and our enemies. To do this, let's jump over to our game scene. Let's come down to our register colliders method. So in our register colliders method, let's come down to our logic where we have our collisions between our player and our various enemies. The first thing we'll do is in our overlap between our player and our various enemy groups. We currently have our enemies take damage when our player collides with them, and we originally added that to allow us to test our health component and having our enemies die. So let's remove that logic, but we want to keep our logic where our player will take damage. And now we'll update our callbacks since we don't need these arguments. Next, we'll want to add in our collision check between our player's weapon and our enemy group. So down in our if statement at the bottom, let's do this, we'll reference our physics, let's do add, and we're going to do an overlap. And so now for our overlap, we want to do our enemy group, and so we'll do our objects by room ID. We'll do this room ID, and it'll reference our enemy group. Now we'll need to reference our player, our weapon component, and then our physics body on our weapon component. Now we need to add in our callback. So in our callback, we'll have our enemy game object as our argument. Now we'll just need to call the hit method on that enemy. And so we'll do our enemy, we're going to do as our character game object. We'll call our hit method. And now we need to pass in the direction our player was facing. And so we'll do this, our player, our direction. And now we need to grab the amount of damage from our weapon. And so we'll do this, we'll do our player, we'll do our weapon component, and now we'll do our weapon damage. Now that we've added in our overlap between our player's weapon and our various enemy groups, now we need to do the inverse. We need to grab a reference to all of our enemies that have a weapon component, and for each of those enemies, we'll want to have a collision check between their weapons and our player. So for the time being, none of our enemies actually have any weapons, but once we get to our boss character, we'll need this logic so our boss can do damage to our player. And so to add in that check, we're going to need to get a reference to all of our enemy weapons. And so let's do const when we can do variable, and we'll do enemy weapons. So now to get a reference to all these, we need to reference our objects by room ID, our current room. Now we want to grab our enemy group, and now we want to call the getChildren method to grab all of our child game objects. And so once we have all of our child game objects, now we want to check to see if that game object has a weapon component, and if it does, return that body of our weapon component. To do that, we're going to use a flat map, and this is going to allow us to iterate through our array of our children, and then we can return a different object instead of returning our enemy game object. So in our flat map, in our iteration, we'll have our enemy, and now inside our loop here, we'll do const, let's do our weapon component. We're going to set it equal to our weapon component. We're going to do get component. We'll pass in our type. And now we want to do our enemy as our game object. So now we're going to check to see if our weapon component's not undefined. So if our weapon component does not equal undefined, then we want to return that. So we're going to return, and we'll do an array. We'll do our weapon component body. Otherwise, we just want to return an empty array. So how flatmap works is it's going to flatten our results we provide through our iterations into a new array. What this means is in our iteration, we need to return an array of the objects that we want to add to our overall array when we're done. So as we're iterating through our enemy game objects, if our enemy has a weapon component, we're going to return that physics body in our array here, and then our resulting enemy weapons array will have that physics body. If our enemy doesn't have that component, then by returning an empty array, no new elements will be added to our main array here on our enemy weapons. So now that we have all of our enemy weapons, we can just check to see if our length is greater than 0, and if it is, we'll add in our new overlap. And so we'll do our enemy weapons, let's do our length. If it's greater than 0, now we just want to do our overlap. So I'm just going to copy this block of code here, and now we'll just update our properties. So instead of doing our enemy group, we want to reference our enemy weapons. So we have that array. Then we'll reference our player instead of our player's weapon. So now in our callback, instead of having our enemy game object, this is going to be our enemy's weapon body. And so we'll do enemy weapon body. All right, so in our callback here, now we'll need to get a reference to our weapon component that's associated with our enemy's weapon's physics body. So when we created our weapon component, one of the things we did is we did our assign component to object, and we assigned it to that physics body associated with that weapon. And so by doing that here, now in our collision check, we can use this physics body and get a reference to that weapon component. And so to do that, I'm going to copy this block of code here. We get a reference to our weapon component, but now we're going to update our reference. So instead of doing our enemy as our game object, we'll do our enemy weapon body as our game object, and now we'll do our check. And so we'll do if our weapon component is undefined, then we just want to return early. Otherwise, we'll want to have our player take damage, and so we'll reference our player. We'll call hit. Now we'll do our direction.down, and then for our damage, we'll reference that weapon component, and we'll grab our weapon damage. One last change we need to add is when our weapon collides with our player, we'll want to call our method for our onCollision callback here, so we can do any cleanup, like hiding our projectiles and disabling our collisions. And so to add in that check, we'll need to make sure our weapon component has a weapon. And so we'll do or our weapon component, our weapon is equal to undefined. We'll return early. And then that way outside here, we can do our weapon component. We can reference our weapon, and we'll do our onCollision callback. Now that we have our collision logic in place, we should be able to test having our player attack our enemies. Let's jump over to our preload scene. We're going to update our starting room. We'll go to room 6. We'll do our door ID of 1. Alright, if we save, let's come back to our browser. If we go to one of our spider enemies and swing our sword, we should see when our physics body overlaps with our enemy, they take damage and they go into the appropriate state. Now if we attack our spider enemy again, they should die. And now if we try attacking our wisp enemy, we should see that we're not able to actually damage them with our physics body. Alright, to come back to our preload scene, let's revert our change, and we'll go back to our starting room. Alright, so with that last change, that actually wraps up our section on our attacking and adding a simple combat system to our game. So with the system we've built here, we can easily extend this later on to add new weapon types to our game, and we'll be able to support those with our weapon component. We've also built out the support that we'll need for our boss and being able to have our boss attack our player. Later on, this could be extended by adding in new enemy types that are able to throw weapons or attack our player as well. So now that we've wrapped up our section on attacking, we're going to transition over to our data manager. That's it for this part of the series. If you found this helpful, be sure to hit the like button. It really helps out the channel. And if you're following along, make sure to subscribe and turn on notifications so you don't miss the next video. If you have any questions or want to share your progress, drop a comment below. I'd love to hear from you. Alright, thanks for watching and I'll see you in the next one.